morning, everyone. This is Julie McDonald with Microcom Technologies, and I'd like to thank all of you for attending today's webinar with IgniteNet Edgecore. Today's host is Dan Kazwara, and he is their field application engineer, and he will be presenting today. If anyone has any questions, please submit them in the question box, and Dan will answer them at the end of today's presentation. Dan, thank you so much for being with us today. We appreciate it. I am finished for now. Please go ahead and take it on over.
Okay, great. All right, thank you, Julie. Hi, yeah, I'm Dan Kazwara, field application engineer here at Edgecore or IgniteNet. Today I'm going to be talking about the Terragraph and some updates we've been doing with the Terragraph solution. Okay, so here's kind of the agenda. I'm going to go over the overall high level about the products from the IgniteNet now to the Edgecore product. Deployment scenarios, some of the software modes in the Terragraph mode or Terragraph product, and ecCLOUD. There's now support for the just around the corner to have support for the MLTG Terragraph product for ecCLOUD, our ecCLOUD, our existing ecCLOUD. And then at the end, I'm going to have some quick startup and tips with the Terragraph product itself, going into some of the basic UI settings and configuration. And then at the end, Q&A. Okay, so you may be familiar with IgniteNet. First to do the 802.11ad based chipset with Proso 2015 with the MetroLing product line. It improved with the 2.5 gig and then the Omni with the 10 gig interface products. And then in 2020, moved over to 802.11ay product, the Terragraph product line with the distribution node and the client node. And now in 2022, there's now a long-range version, client node, point-to-point or point-to-multipoint, which I'll discuss a little more. That product has been in the works, and it's now hopefully available. Actually, we're hoping for the first run of the product available in June. So we're just a month away from getting that, and that's the game changer for using the Terragraph in place of, say, the MetroLing, because it now has we now have a long-range version to work as a complete solution for 60 gigahertz with Terragraph. Okay, so the distribution node is just synonymous with access point or base station. So that's that. It's 360 degrees. You can get various versions of it, like different, which I'll cover. There's a client node. Now the client node originally just was a client node only, basically. But now we are going to have firmware. That's something new to announce in this webinar. It's in the works. We're going to have that also as a smaller scale base station or access point. So it'll have either mode. It'll be a client node or an access point. But the big thing about it will be the fact that it's a very low cost Terragraph 802.11ay base station. Same price point. It's just a different. It's going to be firmware. The newer firmware will support access point mode. And then the CNLR, which is like I said, going to be available very soon, is the long range version of client node. Now that one will really be just a point-to-point or point-to-multipoint. Will not, of course, act as a base station. It's too directional for that. Okay, so what's the big deal about AY? So the main differences with AD and AY, the big difference is running TDMA. That's the biggest, I'd say, notable difference. They're using the same channels, using the same modulation complexity. So the phi rates are the same, but how the network is, or how the data is managed and allocated is improved, right? And so the AD was carrier sense multiple access, collision avoidance, which is like traditional Wi-Fi, and where the 802.11ay is using TDMA. So the TDMA has time slots. There's some advantages of that. One of them is that you can now use the same channel on the same across the entire network. So whether, let's say, our distribution node with multiple radios in it, they could be all on the same channel now because the TX and RX timing are in sync. Okay, so the distribution node. Okay, so this distribution node or access point, it has 4 90-degree radios. Now it's a lot of dB gain, improved from our Omni. It has 28 dB gain at the same time scanning 90 degrees. Look there on the picture on the bottom right corner. That's kind of how beamforming works, where you've got multiple beams you could scan to and talk to various clients with, but the actual specific beam you talk to is narrower. That's how we get the gain way up, because there's no way a 28 dB gain antenna would have 90 degrees of coverage. Instead, the beam itself talking down to an individual client's down to below or narrower than even 5 degrees. And that's where all that gain is coming from. It has a 10 gig SFP port, multiple gig, 1 gig Ethernet ports. There's variations of it. You can get the 4 radio model, which is then gives you the 360 degree coverage, or you can get a 270, 2 versions of the of 180 degree, which would be like one north and south, if you will, another one north and say west. You can get depending on your deployment. And there's a single 90 degree version, a single radio. Now the distances. So for a distribution node or access point to support mesh to another distribution node, we recommend up to 250 meters. Now, this, let's say one is a POP node, that's the one with internet access. The secondary DN doesn't have to have internet access. It could then provide mesh, it could be a non-root mesh or a remote mesh, but also the wired Ethernet coming off of it, or even the SFP plus coming down from it, can then provide wired connectivity at that location too. So that's, it's both. It's, in a sense, it's kind of like acting as a client in that, for the wired side. The distance there also, when it's mentioned there, the 360, talking to a client node up to 150 meters. I actually recommend that just to be only 100 meters to just for maintaining a really good like MCS 12. The reason now is because we do have now the CN LR. So anything past 100 meters, I just say go with the LR. And it goes up to 700 meters. Up to, I'd say I recommend 500 meters. So that would be we're a good, strong link budget, 500 meters or less should be fine. So it's half kilometers, point to multi-point using the LR to it. So here, showing the SFP plus port on it and the RJ. So it has RJ45 or 1 gig Ethernet for management. The management port is actually out of band, separate from the data plane. So the data plane would be your SFP plus or the other LAN ports. There's actually 4 other LAN ports, LAN 1 through LAN 4. You could uplink those ports instead if you don't have SFP plus for uplink. You do have to run 2 separate cables. Okay, here's a deployment scenario with just the MLTG-360, the distribution node or access point. So you can see, depending on in this visual description here, you can see that you don't need a 360 degree version in every spot. So, so this is kind of showing a deployment scenario of that. Okay, moving on to the client node. So the client node, so this is just a radio you'd normally say like a remote, on a subscriber unit basically. 22 dB gain. So you got 22 dB gain talking back to 28 dBi for a distribution node. It's 90 degrees also. Same actually coverage, 90 degrees by 50 degrees vertical. On the distribution node, it's 50 degrees vertical as well. It's the same. The throughput, I didn't cover too much on the distribution node. It's 3.6 gigabits per, that's the, say, typical throughput. The phi rate is the just the 802.11ay kind of standard data rate up to 4.62 gigabits. That's not the throughput. The throughput's around 3.6, a little, obviously lower because of the overhead. It's right now with the way the Qualcomm chipset, it's 50% direction, 50% up, 50% down. It's symmetrical. I know there's been requests for some asymmetrical. That's hopefully in the works for the future, but currently we can just do symmetrical. So it's meaning it's 1.8 gigs up and 1.8 gigs down per sector on the distribution node. On this radio though, it's 1.8 gigabits bidirectional. So it's 900 up, 900 down. So that's, and it has a 1 gig ETH port. So ultimately you're you're going to be limited by the Ethernet port anyways, which is about 940 megabits typically. Now also is can in the future, hopefully Q3 will have it as an access point also. And yeah, obviously a CN to another CN, the range will be very short. So I think the use case for this would be just a very short, say, hop with a couple connections, or you could have some LRs pointed back at it. Also want to point out all these models so far, I didn't mention it with the DN. The DN, the CN, and CNLR are all IP66. Okay, so the CN out of the box, you actually have two LAN port or Ethernet connections. There's the PoE management port connection, and then there's also a secondary LAN port on the radio. Out of the box, the management and the data plane are out of band. They're separate. So you'd have to go to the secondary LAN port to get your data downstream from your, let's say, your subscriber unit. Now you can go into the UI and change that to where the PoE and the data are joined together on the same PoE LAN port, which makes, honestly, in my opinion, more sense, because then you could just run one cable down. We did that update on the 1.3 firmware. Okay, here's just a scenario showing as a distribution node. So it actually has a base, an access point. Of course, the ranges would be relatively short here. This is in this diagram, we're talking like 75 meters or less. So this really realistically would be more likely a couple LRs, I'm guessing, or just a couple shorter connections. Oh, and also with the CN, let me clarify, it does not support mesh. It'd be like the last access point, if you will, in the mesh network. The distribution nodes truly do the mesh between each other. Okay, so and this is probably a more, maybe possibly a little more realistic, where you have some distribution nodes talking to each other. Figure a micropop or a hub home you could do a DN for that. This would be kind of a use case scenario for that. We got, of course, client nodes coming off the distribution node, the access point. Okay, now the LR, I want to talk about this guy. So if you're familiar with the existing MetroLink product line, we have the AD, the ML16035, or the I should say the ML 2.5 6035. That's close to what this is. It's 35 centimeter. It has around 40 dB gain, so it's close to the same dB gain as the 35 centimeter. It has 1 degree beam width, which is similar. Now, what's nice about this is, and I stand corrected, originally I thought it was 3 degrees. It's actually plus and minus 3 degrees. In one of my previous webinars, we said it was 3. It's plus and minus 3, so it's 6 degrees. It does some beam forming. It's not obviously very wide, that scanning that is, but it's enough to where it's a huge improvement in deployment. 1 degree is extremely difficult. It's extremely directional, where 3 degrees, or plus and minus 3 degrees, I should say, is going to be much more forgiving when it comes to alignment and getting the thing lined up, which is much better. And also it allows for some movement. So if you have a pole that's not, let's say, guy wired or something that can move a little bit, now it's more forgiving with a little bit of movement, where before the other, would be pretty limited or not forgiving. The throughput is 3 points, so it's a higher capacity radio than, say, the smaller CN. It's got a 2.5 gig port and 3.6 bidirectional aggregate throughput. That'd be 1.8 in up and 1.8 down. So and then the 2.5 gig, which, if you recall, 2.5 on Ethernet is that's actually that's full duplex. So it's figure you can get 1.8 on each way. It does have also SFP port, but it's just a SFP, not SFP plus, just to point that out. Distances, so an LR to an LR, you can do point to point, and you can go, we recommend up to 1 kilometer for that. Okay, this is showing you got a couple different interfaces. You got a PoE LAN and you got SFP. We want to set the PoE, what I recommend is setting the PoE to both management and the data plane. So then you just run one cable up to the device. Oh, it does have 48 volts DC, direct DC plug in it. So if you wanted to say feed fiber and 48 volts directly to the radio, you can do that. This radio does support that as well. Also, an improvement on this, which before, if you saw the design, it's kind of got that hood that's improved over, say, our MetroLing, the void collection of snow. So it's kind of designed for that to improve on the snow. So we did that. And also the improvement here is also LED indicators for signal strength in your link. So you see the alignment, and then once you're linked up, it'll give you your RSSI. And there's a chart, I should have put it in here, but figure like, you know, one light is -59, two lights is -55, something like that. So that's what you'll see there. And then there's also left, right, up, down. You'll see the arrows telling you, hey, you need to go a little more to the left, you need to go a little more to the right. So it's nice, much better for deployment. It also still has the boss on the top for if you want to mount a alignment scope. So you can do that too. So that's still the same scope that worked on the MetroLing will work on this radio. Here's just showing a point-to-point 1 kilometer. Now you could put this in bridge mode. I'll talk about the modes, but you could do just traditional layer 2 transparent bridge mode, or you can put it in Terragraph mode. But of course, you're not going to mesh between just two of these. So there's yeah. Okay, so here's a deployment where this would be more likely what you'd really see, right? You'd see the access point, the distribution node, you know, in the middle there, some CNs within 100 meters or closer, then some LRs further out up to 500 meters. Now, if you're not familiar with before, I kind of skipped over it. I apologize. I realized that the question might be is how many can I support? The distribution node could support 15 clients per sector. Now, if you have the 4-sector version, that would be up to 60. And also with the client node, the CN in base station mode, it can also support up to 15. Of course, at a lower capacity. It's got a 1 gig Ethernet port, so keep in mind this is a smaller scale, solution for the lower cost solution. But you're losing out on the overall capacity. Where say on a distribution node, you got an SFP plus port on there. Okay, here's just showing, say you did a point-to-point on a further link, and then so just a little bit of different variations. Here's just some more kind of scenarios. Okay, so the modes. Okay, so there's full IPv6. So with the Terragraph, which is another change from, say, the MetroLing product line, previous the 8211 AD stuff, all it did was layer 2 transparent bridge. That's all it did. Where the Terragraph product originally only did IPv6. That was a big problem, actually. Got a lot of pushback because I see the WISPs out there looking for still to support IPv4. And now we've listened, and now we have what we call hybrid mode. So the mesh mode with hybrid is the one really you want to use, because then you get the benefits of mesh, or the options of using mesh. Even if you don't have it now, you could then later on add a distribution node, and then it could be a mesh either way. So it's kind of nice that's the mode I suggested to use. And of course the mesh just works between distribution nodes, DNs. Just keep that in mind. So how it works, it uses a VXLAN tunnel to tunnel the traffic. So it has its own network, but tunneled, so meaning the IPv4 traffic from the beginning to end, it's tunneled, so the IPv4 traffic doesn't see it, right? It's tunneled. So figure your IPv4 network all the way to your client on the other end, that's tunneled, so it then just sees an IPv4 connection. So it's really nice. And then there's bridge mode, where if you want to do that, that's fine too. You could use that's our traditional layer 2 transparent bridging. So you can do that mode as well, depending on what your use case scenario is. Sometimes the simplicity, especially like just a point-to-point link, why not just set it in point-to-point mode or bridge mode? Keep it simple. Okay, so if you're familiar, we have ecCLOUD. ecCLOUD, IgniteNet has, they also manage the Edgecore APs. So it's free, you can go to cloud.ignitenet.com, create an account. It used to be you could manage up to 2 devices for free. It now is 50 devices. So I think that's a really good deal. Within the tool, or I should say within the cloud, is a LingPath tool, which is also free to use. And I recommend you go to it and check it out. It's pretty cool. It's 60 gigahertz, and it also factors in so distance, and then it factors in what channel you're on, because on 60 gigahertz, it really matters what channel you're on. You know, on Oxygen, channel 2 is worse than, say, channel 4. And then also rain. What about rain? So you could factor in rain depending on your rain zone and actually get more accurate, you know, information about, hey, how much rain fade am I going to get? Now, to let you know just ahead of time, people get caught up in worrying about rain fade on 60 gigahertz. And I think that you got to keep in mind, it's additive based on distance. So when you have short links, like say 100 meters, 200 meters, it doesn't really add up to much. And I think worrying about that, you can see the difference here is only like a half a dB, 1 dB. I'm looking at here the rain fade 56 and 57 based on 100 meters. So we're talking about a 1 dB difference. Where it really starts adding up is, you know, 500 plus meters. That's where it, you know, when you get half kilometer and then of course way further than that, then it really adds up. So, but anyways, go on there, check it out. It's free. You could put in certain models that you want to do, and then based on your distance, and then based on your rain zone area, or you know, if you want to put worst case scenario in there, you could get the, which I recommend, always factor in rain. That's worst case scenario. Point out the Terragraph product, if you notice, I haven't talked about 5 gigahertz failover. So the MetroLing has a 5 gigahertz failover. So you can, maybe you can get away with getting a, you know, further distance. You could let it fail over once in a while, where this Terragraph, you have to design it where there's more enough signal margin in mind where that, you know, there would, because you don't have the failover to 5. So you have to obviously shrink everything in a little bit, but the EIRPs are much higher now with the Terragraph. So the link budgets are much bigger. You know, we have, compared to our Omni, which had 18 dB gain, this Terragraph has 28. So it's 10 more dB gain. The output power is about the same, a little more actually, 15, 16 dBm. So instead of 14. So, you know, it's a little more. And then of course, even the client nodes have higher gain. Well, at least the CN has 22. The LR has around 40. So the MetroLink was like around 42. So we're talking pretty close. But overall, there's a lot more system gain in there total. So anyway, check out the tool. It's free. You can find out like distances. Okay, and also the ecCLOUD has within like the mesh, it'll which is kind of cool. Oh, and I haven't mentioned it. Okay, so the Terragraph product currently, the cloud does not support the mesh, but they're working on it, and it's hopefully going to be available in about a week. Now, they've been fine tuning some things, and it's kind of been delayed a little bit, but we're supposed to have it pretty soon. So hopefully about a week from now, I hope so they'll be available to be added to the cloud. Now you have to have version 1.3 firmware or later, which on the Terragraph product to even have the option to select, can I connect to the cloud? Yes or no, turn on the cloud agent. So I'd say look out for that. If you already have the Terragraph product, look out for that. It's going to be coming out pretty soon, support on the cloud. And so anyway, to cover this part in the slide, it's showing it in the hybrid mode or full IPv6 mode. You'll have the mesh where it'll show the topology of your mesh on your cloud. So it's kind of nice. Okay, this slide's just showing, you know, how, if you're familiar with our cloud, just how our devices show up on the cloud, and you know, which their names and their firmware version, stuff like that, basic stuff. Okay, now I'm going to quickly kind of change gears. For the sake of time, I'm kind of going to go through this quickly. So setting these up. So the first thing I want to cover, if you purchase one of our CNs and you have the original 1.0 firmware, there is a, out of the factory, there was an issue with the reset. So all I say is go into SSH and do a reset. There's a procedure on our website to do it. All you do is go into SSH and type in the command, and then you can then log into the UI. It's kind of interesting. We had a little issue with the first run. So if you happen to get it, just keep an eye out for that. Just a little tech tip. Another thing is loading the firmware. So there's actually a primary and an alternate boot bank on all these products, and also our MetroLing products. And the really old firmware, we want to flush out the really old firmware. So we actually recommend you load the current latest firmware twice. So then both the primary and alternate boot banks have the current firmware. So in case it does fail over to the different, alternate boot bank, it doesn't go to this really, really old firmware, which may not even be compatible potentially with the newer firmware. So we recommend that, and then we recommend doing a factory reset because there's been a lot of updates since the original firmware. So if you happen to get one of the original, let's say, units that were originally shipped, and it's never know how long they've been in the warehouse. It varies. So so you might have like older firmware in there. So just keep that in mind. So load the firmware twice, factory reset the radio, then go from there. Okay, another one is this is on the client node. So set the PoE uplink port role, the PoE port to LAN. So then you'll have just one cable to run. By default, the secondary LAN is the data port. So just switch it to set it to LAN here in the UI, and that's better because you'll just run one cable. Note the wireless MAC address. So the wireless MAC address is how these guys communicate, right? How they link up. So when you're in the UI loading new firmware, get the wireless MAC address. The node MAC address is less important. Now, if you figure it out, on the unit itself or on the box, that's the node MAC address or the Ethernet MAC address. But the wireless is just 2 hexadecimal characters further up. So that's another way to get it. But the easiest way is just get it in while you're in the UI doing a firmware upgrade. Grab the wireless MAC address at that time. Copy it, paste it, so you don't get a typo there. The DN, the distribution node. Now, one thing I want to point out, a couple of times, and I noticed it on the CN also, on the DN, sometimes it doesn't come up in Google Chrome. The UI just doesn't come up. Use a different browser. I'm not sure exactly the root cause of this, but I've seen this. So just use like Edge or some other browser. If you could ping it and you just don't see ain't coming up on the browser, that's the first thing I would check. Change the browser. Another thing, let's see here. Yeah, so the IP address, so 1.20. Okay, client node, let me just reverse back. The client node was 1.20. The secondary LAN port is actually 2.1. It's kind of funny. So depending on which port you connect to, you could actually talk to the management or get into the radio either way. So, but here it's 1.20. The management port is the PoE port. Okay, not to be confused with the other ports. Those are all data, like uplink, downlink ports. Those are separate. The management's always going to be out of band with the distribution node. So you have to run 2 cables. You could run LAN 1, like the secondary LAN 1 for your uplink, so you could have 2 Ethernets. Of course, you're limited now with only 1 gig, but or you could use the SFP plus, which is obviously the ideal connection. Okay, same thing, load the firmware twice. Now, if you have the older firmware, 1.0, there was, you can't just load currently we're at 1.3 firmware, 1.3.0. You can't just load it straight to 1.3. You have to load an intermediate firmware 1.1.2. So if you go to our website to get the firmware, download both 1.1.2 and the latest 1.3 currently, and then install 1.1.2, then install 1.3, and then install 1.3 again to flush out 1.1.2. So now both primary and alternate boots are 1.3, and then you reset the radio. Okay, then you're done and then from the future, I'll say the future is, if you have these on the cloud, you could always push firmware updates much easier, let's say later in the future via through doing it via the cloud. Okay, so to get these to link up, so you notice I made it a point to remember or write down all the, let's say you have 10 client nodes you want to connect to a distribution node. You want to get all the wireless MAC addresses of all those client nodes. You want to note those. So as we get further along in the distribution node, now that you loaded the latest firmware, you want to, this is actually to set this up, right? Get it going. Out of the box is not set to pop node. So you need to set it as a pop node. So enable that to be on. So then it'll be the one that is like the root mesh, if you will. So the other thing is you want to generate IPv6. These are like dummy values. This is for the VXLAN internal OpenR routing that the POP node's doing to communicate with the client nodes. This is required. It's now the hybrid. This will automatically tunnel, so you could this will work for your IPv4 network, but this step is required. So like I said, this is just a step here is to turn on the POP node and generate IPv6 values. The last thing is the control VLAN has to be entered in. I just put in a number. I don't usually, you don't really need to, you could put in a number that you don't use, but it's required. The next thing is now, okay, so in the DN UI, you'll see that there's two options. There's their node settings and link settings. So the node settings is where you basically enter in all the nodes that are going to be connecting to the network or to this DN. It's not setting up the links yet. All you're doing is putting in information about those CNs that will be in the future. In the next step, creating links for. So here you'd systematically just enter in these wireless MAC addresses and enter, and you'd have a list of all these client nodes. Those are going to be your list of nodes under node settings. The next step would be then to go to link settings and then create the links themselves. So now you have all these client nodes entered in. You then can have a choice of which of the 4 radios you're going to use, radio A, B, C, or D on the DN. And then on the CN side, you would just, obviously you just have radio A, there's only one radio on the CN. And then you would create your links. So you have to know obviously which radio, you know, depending on the direction, which radio you need to be, your client node will be talking to. Will it be, you know, radio A, radio B, C, D, depending on the 90 degrees of, you know, where it's low, you know, where it's going to be talking to. Want to point out there in red, the default channel is channel 2. You can change it. There's not much huge benefit, but what I want to point out is that all of them, all 4 radios can be on the same channel because of TDMA. The transmit, if you recall with TDMA, the radios all transmit at the exact same time, so you don't have a near far problem. So that's different than our Omni in the past, where our Omni had 3 120-degree sectors, and they were on channel 1, 2, and 3, so they wouldn't interfere because there was no syncing between those. It wasn't TDMA, so it's a huge advantage. So I want to point that out. Yeah, okay, so let me move on. Okay, and then after that, they should be starting to link up. Now there's 2 things. There's the RF link and then the VXLAN tunnel. So once this is linked up, you're going to see an RF link first, and then you got to verify also the VXLAN tunnel is established, which might take, this whole process might take a few minutes. So you have to wait 2-3 minutes and then the RF link should come up, the VXLAN tunnel. You could have an RF link, but if you don't have a VXLAN tunnel created, which it should self-create. So it should, if you got one, you should have the other, unless there's a problem with your, say your settings, but this should automatically occur. And therefore then once the VX tunnel is created, then your now IPv4 traffic can then work from end to end. So that's kind of how you want to get this going. Okay, and quickly, a couple extra tips. So there's no reset button on the distribution node or the client node. Okay, so how do you reset it? Okay, if you're not able to get into the UI, there's a power sequence reset procedure. You reset, you power cycle it, you power it up 5 seconds, and then 1 second you power it off, powered on 5 seconds, powered off. So it's kind of, it's actually in our instructions in our user manual now with a little more detail on how to do that. But anyway, it's a power cycle. That's how you reset the radio. And you could set it here. It's in the settings. You can see here in the screenshot. But people ask, well, where's the reset button? That's how you do the reset on these. Another little tip. Another thing is, okay, so which radio is A, B, C, D, right? So this is kind of another tip. Maybe I just thought of this, that maybe face radio A in all your installs to north. You know, try to center it as best you can. So then in future, when you go to do, you know, add a client node a year later, you know, then you'll know pretty easily which radio to tell it to connect to. Okay, connected to the cloud. So on 1.3 firmware and later, you'll have the cloud agent. By the way, its default's off, so you'll have to turn it on. So the second caveat is that of course, our cloud has to support it. Our cloud is still being worked on it to support it, but anyway, I don't recommend using it yet, obviously. We'll announce it shortly, pretty soon. It'll be officially announced that our ecCLOUD is supporting the Terragraph product pretty soon. Okay, and that's it for Q&A now. Julie, I'll let you take it.
Thank you, Dan, very much for that wonderful presentation. And we do have some questions for you. Let's get started with the first one. Regarding Terragraph, can you tell us about the warranties on those devices?
Yeah, it's a 2-year warranty, I believe. Yeah, it's the same as the IgniteNet and Edgecore. It's a 2-year warranty.
Great, thank you so much. Let's jump right into the next question. Is the 60 gigahertz only going to be available with the Terragraph products?
I'm not sure the question. It is 60 gigahertz only. It is. It doesn't have, if the question was, does it have the 5 gigahertz failover? It does not.
Thank you so much for that. Next question here for you. Regarding the MLTG-360 or any other Terragraph devices, are they powered via PoE?
Yes. So the client node just takes 48 volts, half an amp, passive PoE. The LR is also passive PoE. The distribution node is also passive PoE. The distribution node does take a lot of power. It's 48 volts, and I think it's 1.5 amps or something. It's pretty high power. It's not, to be confused, it's not 802.3 or AT or BT. It's not. It's a different wiring. It's the passive PoE wiring scheme, so it's a little different. But yeah, it's PoE. Now, the LR and the DN can also be powered via direct DC 48 volts. Only the little CN does not support that.
Thank you, Dan. Next question here for you. It says here, I can see that the devices come in an optional PoE device. Will a third party work flawlessly with it as long as it provides the right power output?
Yeah, I don't see any issue with that. I mean, it's passive PoE. If you want to have, like, I don't know, a Netonic switch or something that does passive PoE off a switch that supports that, or third party, as long as the pinout's the same and you have enough current. It's just the voltage is, if it's 48 volts, it's just, do you have enough current to support the power? The CN and the CNLR are not really big power hogs, and I think, yeah, pretty much most, let's say even competitor PoEs would probably work okay. What I'd be concerned about is the distribution node is a beast, and it takes a lot of power. So we do have the optional, the PoE you purchase separately, but yeah, you certainly source your own. Just pay attention to the power draw. I think it's like 60, I forget the power. I think it's 60, 65 watts, 70 watts or something, peak power. So that's a lot of power. So that's why it's like at the 1 point, I forget the current exactly, but it's like 1.5. So 48 times 1.5. So it's up there in power.
Thank you for that, Dan. Next question here for you. With the mesh mode, will this work on top of PTMP settings?
Not really sure the question. Because, okay, in mesh, yeah, point to multipoint is what it's doing. Okay, so, well, okay, I kind of think maybe this is the question, but you could have one distribution node, the POP DN, and then another, remember I mentioned there's 15, you could have 15 clients, but one of those 15 could be another DN as a mesh to it. So now you're down to 14 clients that could be CNs. So I hope that answers the question. So you could point to multi-point, but also if one of those, let's say, connections was another distribution node, that is now a mesh. So you could potentially connect that, and so that, I hope that answers the question.
Yes, thank you so much. A couple more questions here. Next one, is LingPath a free software or requires login and user access?
Yeah, it's free. You do have to create an account, but it's free. Just go to cloud.ignitenet.com. You could create an account for free. And in the cloud, like I said, it supports up to 50 devices for free. Those are all our MetroLing products. The Edgecore Wi-Fi 6 APs are supported. And then, like I said, very closely, right now, very close, we'll have the Terragraph product also supported on the ecCLOUD. So 50 devices. And then, yeah, the LingPath tool is free in there too. So yeah, free. Just create the account and you can start playing around using the LingPath tool for 60 gigahertz. Like I said, and it's a really good tool because it also factors, I like the fact that it also factors in rain, which is really a big plus.
Thank you for that, Dan. Next question. Regarding ecCLOUD, does this only support the Terragraph line?
Oh yeah, so that I think I just answered the question. Actually, no, it's it's fine. It goes all the way back to the original IgniteNet MetroLing product line, all those indoor and outdoor APs under the IgniteNet product line, and also now all the future Edgecore indoor and outdoor access points. I shouldn't say every single one, but most of the Edgecore models. So yeah, it supports a lot of stuff. I'll go even one step further. There's now going to be cross support, if you will, with our ecCLOUD with open Wi-Fi tip. So there's even that. So there's yeah, the thing is very flexible. There's a lot of stuff on there. And so ecCLOUD's, I think, and I've worked in different vendors and stuff, it's one of the easier, nicer cloud solutions out there. Real easy to use, easy to find stuff, easy to maneuver and get information. It's very intuitive, I think, compared to some other clouds out there. And I've heard the same with other people too. I'm not just saying that because I'm here at Edgecore here talking about it, but it really is a nice, easier tool than some other competitors, and not just my opinion, but the feedback I'm getting.
Excellent. Thank you, Dan, for answering all of those questions for us today. And thank you to everyone for attending today's webinar. And if anyone has any further questions, of course, please feel free to contact your sales rep or email us at sales@microcomtech.com. And if you wish to view any of the products mentioned or shown today, please visit us at www.microcom.us. And remember, this webinar presentation has been recorded and will be uploaded to our Microcom YouTube channel so you can view it again. Thank you, Dan. Appreciate all of your information today and for sharing it with us and for taking the time to being with Microcom. And until next time, everybody have a fantastic day.